Let's take a look at client-side architecture in DoneJS. By definition, DoneJS is an MVVM architecture, which is short for Model, View, viewModel. Where models handle the data layer and interact with the server, views handle the DOM and rendering the UI, and our viewModels are the middleman handling complex application logic. For this video, we're going to focus on DoneJS's uniquely strong implementation of the view model. Our view models have special per-property hooks that can define the type of value, serialization, initial value, getters and setters, and what happens with the removal of each property. This allows developers to write expressive view models that are not reliant on the DOM. To explore this concept, let's take a look at a real-world example. Here's the Place My Order app that you can build in the DoneJS guide. We are looking at specifically the state and city selectors, where we have loading indicators, and when a user selects a state, it triggers the loading of a new list of cities. Traditionally, solutions for this are messy, and the views and view models are reliant on each other, but with DoneJS, this is not the case. Let's take a look at the actual implementation of this. Here's our view template. We are strictly handling just the UI logic here, when to show the loading states and when to show the list of available options. Here you can see that if the states are loading, we just display a loading option. And once they have loaded, depending on if the user has selected a state, we'll show a choose state option and then the list of all the states that have loaded. The same thing happens with cities. If cities are loading, we're going to show a loading state. Otherwise, we're going to show the list of all the available cities for that state and the choose state option if the user hasn't selected, the choose city option if the user hasn't selected a city yet. From a high level, this is what our view model looks like for this. We have the state property, which is the user selected state, the states property, which is the list of available states, the city property, the user selected city, and cities, which is the list of available cities. Let's take a look at the define for states and state. For states, we just have the getter defined, which returns a list of states from our state model. This can be an asynchronous request to the server, and thus it returns a promise. This allows the views to easily create loading states by checking if the promise has been resolved. For state, we just have the setter defined. So every time that the state is set, it's going to make sure that our city attribute is set to null. For cities, in our getter function, first we check if the state is set, and if it's not, we're going to return null. Otherwise, we're going to return a list of cities where the state equals the user's selected state. This is also asynchronous and returns a promise. For city, we're just specifying that the value is by default null. Let's see how this all plays out. On the initial load, our states show a loading state, and that's because our states is a resolving promise. Just like we talked about in the definition of the getter function, it's returning a list of states from the state model. Once they have resolved, we have a list of state objects, and the user is able to choose a state from the dropdown. Once the user has selected a state, it triggers our cities to load a new list of cities for the state. That's because cities is a computed property that's reliant on the state property. So every time that our state property is changed, it's going to recompute our cities list. In this case, it's going to get a new list of cities where the state is equal to Wisconsin. Once that promise has resolved, we have a list of cities, and the user is able to choose a city from the drop-down list. So the user can select, in this case, the city Green Bay. When the user chooses a new state, in this case Illinois, it's going to do several things. First, on the setting of the state, it's going to set our city attribute to null. And the second thing is, when our state changes, it's going to recompute the cities list, returning a new list of cities where the state is equal to Illinois. So let's take a look at this again in the finished product. The user chooses Wisconsin, it loads a list of cities from Wisconsin. Then the user can change the state, and it'll load a list of cities from the state of Michigan. Unit testing this functionality is pretty easy. Our view model handles all of the complex logic, which means we don't have to bring in the view for our unit tests. An example of one unit test might be setting a state loads its cities. All we do is initialize a new view model, and we create a list of expected cities where we check the city store for all the data where the state is equal to California. We first verify that our new view model instance, the cities list, is empty. And then we set the state to California. We'll get our list of cities, and once that promise has resolved, we check that the list of cities is equivalent to our list of expected cities. As you can see in this unit test, we didn't have to call in the view at all. We simply just use the view model. The end result is that we have very expressive view models that cover all of the functionality of our application, which makes for very testable application logic independent of our views. Our views are logicless and can be switched out and changed out without risk of breaking core functionality. This is what makes DoneJS's client-side architecture so uniquely strong and easy to work with. Thanks for watching and your interest in DoneJS. If you have more questions about our view models or DoneJS's architecture in general, post them in the comments below. Thank you again for watching and checking out DoneJS.